All right, so let's get a graph up and let's talk about, do you remember this was a new parent one I just showed you the other day? 1 over x squared, that's correct. Y equals 1 over x squared. And if I wanted that whole graph to move to the right, I would just go like this, minus 2. Now it moves to the right too. Grab these guys, move them to the right too. Okay, so if I wanted to move the whole thing up 7, I'd put a plus 7 on the outside. Do you remember I was also talking about how I could do a bigger on bottom, bigger on top, same on both kind of deal for this, for the asymptotes? All right, I'm going to move this up 1 and then actually grab this graph. There. Now these asymptotes have moved from the original ones. Tell me, what's the vertical asymptote? Horizontal asymptote. Then tell me the limits for all 4 spots. Limits of the function. As x approaches. And I take that and I clone it 4 times. Do your best. Answer all 1, 2, 3, 4, 5, 6 little questions about this thing. I'm going to pause that while you do that. Let's see who in here was getting this right. The verticals are the things that are x equals things. The horizontals, it looks kind of like a y that's been flipped upside down, right? Just take that y, flip it upside down, see? So the horizontals are the y equals things. So the x equals is the stuff that would crash it. 2 would crash it, so x equals 2 is a vertical. Horizontal, y equals, well, Bob will tell you about y. And the y equals, Bob is an outsider. Remember that now? That's 1. Don't say y equals 0. Say whatever's on the outside. If there happens to be nothing out there, then you say 0. All right. So the next one is the limit. I'm going to go to the left end. That's negative infinity is way over this way. So where would it go to? That dotted blue line, which was basically based on the thing moving up 1. Okay, so then that must be, because again, this moved up 1 from normal. Right? So it's at 1. So that means that this, when I go forever this way, this line would get closer and closer to 1 and would level off about 1. And then the limit of the function going the other way to infinity means way over here, and this function would get closer and closer to 1. The limit of the function as it gets close to the middle, that's where you're getting closer and closer to this. I would get closer and closer to what number? 2. And I could get closer and closer from this side, which would be out where the negatives are. So 2 from the negatives. And then if I say from the negatives, I'm coming from over here, and I get closer and closer to 2, and that 2's right here. And then it doesn't ever get there, though. It gets forced up to positive infinity. And then 2 from the positives means starting over here, I come this way, and I end up on this line, and I end up being forced up to positive infinity also. All right. How many of you feel comfortable with those topics? Okay, good. Next topic. Let's flip it, and let's say you have no picture, but you have all the limits. You have to make a picture. This was kind of hard for last hour. I'm expecting it might not be easy for you either. So do your best, give it a shot, and then I'll talk it through, and we'll do another one. All right? Limit of this function as x approaches, and I'm going to say equals, and then I'm going to use the wonders of technology to group these, and then also make it an infinite cloner. 4 limits. As I go to positive infinity, it will be negative 2. As I go to negative infinity, it'll be negative 2. As I go to 3 from the positives, it'll be infinity. And as they go towards 3 from the negatives, it will be negative. Trying to make the picture for this one. My advice is put in the asymptote line. Figure out where the asymptotes must be. Okay, here we go. I hope you put in the asymptotes. Remember, these kind of asymptotes are the ones that go up and down, and it's going to go up and down at 3, so I'll put it right there. This kind of asymptote is at the other way, okay, and that goes across like this at -2. And this again was the kind that's a vertical asymptote, and that goes at 3. And so now it's not too hard to figure out when you look at a first couple of these limits. The limit, if you go way to the right, is -2. So that means it's going like this. Can you see what's going to happen here? That's going to go up like that, but I don't even know that for sure yet. But I think so. Okay, so it's going to go down like this. I know that. Next one, this one, if I go way to the left, it's going to be -2. Okay, so that means that somehow, either it's this way or this way, I don't know, but somehow it's got to end up at -2. The next thing I'm told is that getting closer and closer to 3 from the positives, that's from over here, this is going to have to go up to infinity. So it has to go up like this. There we go. That one must be like this. And then logically, this one's probably like that, but let's make sure it really is by double checking this. Going towards 3 from the negatives. Here's from the negatives is over here. Going closer and closer to 3, I'm going to be forced down there to -infinity. Yep, that's right. So there's my answer. Looks like that. Any questions about that one? All right. Great. I need to be honest here. How many of you got this right without my help? That's almost everybody. Then you probably don't need to do it again. Or do you want another one? There is one on your homework, I believe. Okay, yes. Nope. Just have to be able to, for this kind, they give you all the limits, they just want the picture. All right, next kind. There's a lot of stuff to know. Let's go to a different kind completely. Let's say it's like this. Now plus in there. Tell me what that graph would look like. Sketch it. Now I'm not going to ask you to check the y-intercept on this one because it would be too big. It'd be 9 times 125, so that's insane. Don't worry about the y-intercept on this one, but you will have to do that on the test. So know how to do y-intercepts. The y-intercept is where x is 0. So you just remove the x's and see what you get. But don't worry about that for right now. Just sketch this. Do you get that it has to be going down on the right because of that negative in front? That's one of the first things I want to know. Is how does it end? And then do you get that this thing is a degree 5? X squared times the negative times the x cubed would be negative x to the 5th is my lead coefficient. I wrote that kind of funny. I'm going to try that again. Negative x to the 5th. Okay. So the lead coefficient is negative, so it's going down on the right. The fact that it's odd means it must be going up on the left because odd things go in opposite directions of each other. Okay. Now it's got to be touching at 5 and at -3. And what is it doing at 5? It's doing one of those funky ruts at 5. Like that kind of a deal. And then through the 3, it's bouncing. It's not really through the 3, it's at the 3, it's bouncing, and that actually makes sense, so it can go up this way. And if we wanted to check the y-intercept, I'm not going to know exactly what it is, but I would take the y-intercept of x is 0, and that's gone, and that's gone. Negative 5 cubed would be negative 125. And you'd times that by negative 9, because 3 squared is 9. Negative 9 times negative 125 would be positive like 1,000 something. So yeah, this is up here, but I don't know how high. It's probably a lot higher. Don't want to make it to scale. Okay, that's a good enough sketch though for this graph. I could label this as, I don't know what it, 1,025 or whatever this comes out to be when you multiply. And I'd label this as negative 3 and this is 5. All right, one more like that. This time I actually want you to do the y-intercept. Tell me what that would look like. Make a sketch. Include the y-intercept on your graph. Right there. Draw the picture. So I'm going to have a kid come up here and get this started. How about this kid right here? Why don't you come up and start the graph? Don't you know how it ends? Okay, start that. Just go ahead. Get up. Step. Not that hard. It's really pretty easy. All right. Just the ending. Just the very end. You know where it ends, right? Or do you know where it ends? Do you know that it ends going down, or do you think it ends going up? What do you think? Well, how about this? Do you get that to figure this out, you have to go this times this and get that lead coefficient? Just tell me verbally. Would that be positive or negative? Okay. How about this? I want to pause for a second. We're going to graph this thing. Okay, so I graphed it quick. Here it is. It's negative in front. That's a negative, not a minus sign. 3 minus x squared, and then x plus 1. And I hit graph, and it looks like this. All right. How many of you had it right? Raise your hand if you did. Okay. Now, for those of you who didn't, I bet you were thinking that it was negative and therefore going down at the end. Or, sorry. I bet you thought it was positive and therefore going up at the end. Here's why I think you could have made that mistake. Think of it this way. If I just take a negative times a negative, that makes it positive. Shouldn't the lead coefficient then be positive x to the third? What's wrong with that argument? Because I just graphed it a second ago, and I can tell you it's going down on the right. Therefore, it is negative. It's not positive. Yes? Yep. Negative x squared, isn't that going to be positive? And then you have a negative. So it's negative. And then the x squared with another x to the first makes it x to the third. And there you go. So it is negative. It's going down on the right. Okay, that's one thing we knew. It was going down on the right. Next thing. Oh. There. Next thing, it's got a root at, if I put a 3 in there, that would be a root. If I put a -1 in there, that would be a root. Touches at 3, touches at -1. Going down on the right. Once eventually all the pieces come together, you'll know what to do. Next thing is, find the y-intercept, because I want a dot somewhere along here. I don't know if it's up here, if it's down here, or where. So, I'm going to stick in x is 0. Put a 0 here. 3 minus 0 is 3. 3 squared is 9. It's -9 times 1, which would be -9. So, the y-intercept is -9. It's way down here. Alright, so the piece is starting to come together. You know it's got to end like this. It's got to be a... Is it a bounce or a cut through at the 3? See that too? It's a bounce at the 3. Bounces, goes down here. Now what kind is it at this? There's no exponent there, so there's a 1 there, so it's a cut through. Here we go. Long time coming, but there's your answer. Alright. One more like that. We'll change it from an x to a 3. And you can actually keep the graph on the... There we go. There. Try that one. Make a sketch. Do you guys know what the multiplicity means? That's a multiplicity, and that's a multiplicity. This root of -3 has a multiplicity of 2. And the root over here at x equals 1 has a multiplicity of 3. It's a triple root. It's a snake. This one's a bounce. It's a snake. Alright. So the picture for this would be, gotta have a -3 with a dot at it. I gotta have a 1 with a dot at it. I gotta have it snaking through the 1. So that's one of these kind of deals. Those are really hard for me to draw, but it's changing rates right at that point from increasing at increasing to increasing at a decreasing. Probably be even better if I go the other way. I can usually draw them better that way. Okay, and then I'm going to go. Ooh, y-intercept. Y-intercept seems important. You put in a 0 here and here, and get 3 squared is 9, and then -1, 9 times negative was -9. Okay. And then, what's it doing at the negative? We're at the -3. Bounce it, boing. And now when you're all done, you can double check yourself and say, it seems like I've got an odd answer here because it's going opposite directions. Is it an odd degree? Yep, degree 5. If I wanted to, I could do x squared and x to the 3rd makes x to the 5th. It's my lead coefficient. It's positive on the right, or it's going up on the right, so it must be positive in front, and it is. All right. Whew, a lot to know on this. Lots of limits to know. Multiplicity. Writing limits. Graphing. We did some sketching. All right. We did a lot of sketching, but we haven't done any actual, like, graph this. Sketch different than graph? Yes. Graph, you have to actually have accurate points. So I want to see if you can do this one. I'll give you a hint, though. The parent of this one is 1 over x squared, and the parent of that one looks like this. Okay? I want you to take a second and try to graph that. Actually, the nice way where you actually have labeled a few points on it so that you're accurate. as opposed to a sketch where you can just kind of make a rough draft. Pausing while you do that. Okay, here's a quick general idea where it's got to be. All right, the parent looks like this, right? So I guess I have to take that, and what is the plus? Oh wait, should I start with the 3 or the 2? 3 start on the inside. And where should I move it? Right 3. So take this thing right here and I move it to the right 3. 1, 2, 3. Say that's right 3. And then what's that plus 2 do? Up 2. 2, 2. My new asymptote line then are at that. Yeah, that'd be a 3. Be a 2. Okay. Now, how accurate is that? Not terribly. If you really wanted to make it sure you had some accurate points on here, you'd make an XY chart. I strongly encourage you to do that on the graphing test. Last time we had a graphing test, it was the cumulative. And on the cumulative, a lot of you guys would have caught mistakes that you were making if you'd have only made a little XY chart. Okay, so I don't want to figure out like really weird things for this. I want it to be nice numbers because I'm going to have to square it and it's on the bottom of a fraction. So maybe like put in, well, if I put in a 3, do you get how it's going to actually crash this whole thing? And that means that there should be an asymptote at x is 3, is there? Not good. Let's put in something like 4. If I put in x is 4, let's see what happens. 4 minus 3 is 1, 1 squared is 1. What's 1 divided by 1? 1 plus 2. 4 comma 3. Over 4 comma up 3. That's that dot right there. It's on my graph. Must be doing it right. Maybe I should check one more, just to be safe. So maybe I should check like 2. Put in a 2 right here. 2 minus 3 would be negative 1. Negative 1 squared is also 1. So it's 1 divided by 1 is 1 plus 2 is 3. So negative 2, sorry, goes also with 3. Might not seem like it makes sense, but then when you actually graph it, it does make sense. 2 comma 3 would be right there. All right. So it looks like I was doing it right. Use this in your graphing test. It's really smart to have an XY chart. Okay, I think I've done enough problems for you. So what I'm going to do now is